In the GDA 94 to 2020 conversion for an enterprise system, we've set up a repo on the Azure platform. There's a couple of different things that happen. You can see in here, we first have a explore phase, which runs a couple of scripts where we can then get the metadata and then visualize that metadata. And then there's an investigate phase where we can then go through the data partly manually and maybe clean up for duplicates or check the schema and check the usage. And then we go through the reprojection phase. Once that's reprojected, we have some supporting things that can create the relationships and bring in the views and things like that. And then that can all be batched and checked. And then there's a QA process that not only checks the data one against the other to see if nothing but the projection has changed. Also, we do get 10% or 5% of the nodes to see if they've actually shifted by the 1.7 meters or so. This is all coordinated through a text file that tells us the process to run one by one. The first thing is to get that metadata, and then you just put in the SD connection where you want it output and the credentials. So that can take a day or so to run on a dataset like CorpDB, or it can take 15 minutes to run on a smaller dataset. What that allows us to do is to see the DB when we ran it. You can see that there's 53 datasets and the number of feature classes or tables within. And then you can see there's 5 tables in that whole. There's no relationship. There's only one. So you can also see the metadata coverage. You can see in the administrative boundary, there's 35 with metadata and 53. And newer versions of this script also show you which ones did have metadata and what that metadata was. So once the metadata is run, you can also look at it in different ways. So one way is where this like a mind map of it. So you can see that's the tenure data set, and you can see that there's polygon data just by the icons, and the size of the icons also shows. You can see the 2757 records, and that one only has 18, and that's why it's smaller. So it's just a visual way of looking at it, and you can see the same with these as well. You can also view it in different ways, and one of them is a text which just breaks that down. So if there are multiple schemas, it would be start with the schema and then go data set and then the data types. When we run the reprojection, it's basically you give it the source and the target and then the XML, and using the N2V2 conformal and distortion. And then these are basically just parameters that are fed in. So while that's running, you can monitor the progress. Some things might take 3 days or more to reproject, and others might take a few minutes. So we run a quick validation, which checks the projection has changed and also looks at the counts and sees if they have changed. And then we can analyze the logs. Also, when we analyze the logs by running a script, we can see a comparison like this that shows us that most of them are the same, and you can see that there's no issue on those. On these, you can see that on this one, the issue is there, but it's not a major thing. It's just that some of the types we've solved for that later. Basically, you can. So what happens sometimes, especially on big data sets, is that the ArcGIS license expires and then it continues with the next one. So we basically rerun the script, but on the second run, we give it a filter file. It gives it a list of all of the files that didn't reproject correctly, so it only runs on those. But you can also see that we could just run the whole script again and just change this. So if we change this to false, the skip if target matches, then it would run again on everything, but you'd keep it as true, and then it'll check that the feature counts are the same and the geometry is the same, and skip it if it needs to. So that's all documented also, as we said, in the repo, that whenever there is a Python file, there's an MD file that goes with it. And there's also these README files for each section as well.